Okay, today we're going to talk about Module 4, which is evaluating and solving trigonometric equations, expressions, all that fun stuff. But before we really get into that, we've got to go back over these identities, the reciprocal identities. So we know that the sine of theta is equal to 1 over the cosecant of theta. We know that the cosine of theta is equal to 1 over the secant of theta. We know that the tangent of theta is equal to 1 over the cotangent of theta. And then we also have those reciprocals. Cosecant of theta is equal to 1 over sine of theta. Secant of theta is equal to 1 over cosine of theta, or whatever the angle is. Cotangent of theta is equal to 1 over tangent theta. Okay, next are the quotient identities. So we know that tangent of theta not only is equal to 1 over cotangent, but it is also sine over cosine. Recall in the coordinate plane that it's y over x, and remember our sine was our y values, our cosine is our x values. Cotangent is going to be the reciprocal, because remember it was x over y. Then we talked about Pythagorean identities. Our Pythagorean identities, the first one was the sine squared theta plus cosine squared theta is equal to 1. And remember, this just means that the sine of theta squared plus the cosine of theta squared is equal to 1. Okay, we also had 1 plus tangent squared theta was equal to secant squared theta, and 1 plus cotangent squared theta is equal to cosecant squared theta. Our cofunction identities, we have sine of theta is equal to the cosine of 90 minus theta, or I could say pi over 2. And likewise, the cosine of theta is equal to the sine of 90 minus theta. Then we have our secants and cosecants. And then we have our tangents and cotangents. And after we've done all the graphing, we know that these each exist within the same graphs. They're just phase shifts away from the other. So sine and cosine, they were both represented in that curve. Cosine started at a max, where sine started at a midline. Secant and cosecant, they are also related, so it doesn't matter. They're all going to look like this. Just depends on where the function starts. And then, of course, tangent and cotangent, they are a phase shift away and reflected. So they are still co-functions, still existing on the same graph. Okay, odd and even identities. There's only one even, or one set of evens, and that's cosine. So if I have a negative angle, it's still going to equal the cosine of theta. And secant of negative theta is still going to equal the secant of whatever that theta was, positive. Those are my evens. My odds are anything that has to do with a y. So we've got sine of negative theta is going to be equal to a negative sine of positive theta. And likewise, the cosecant of negative theta is going to be equal to a negative cosecant of a positive theta. And a tangent of a negative theta is going to equal a negative tangent of a positive theta, and a cotangent of a negative theta is going to equal a negative cotangent of a positive angle. Those are our odd and even identities. Again, there's only two evens, that's cosine and secant, and that has to do with the x. Anything that has a y is going to be odd. And then we also discussed, like even with the arcs, those with y's, they're limited in their arc values to quadrants 1 and 4, whereas with cosine we talked about that's limited to quadrants 1 and 2. Evens, odds. Okay. Now, you're going to have to know those identities, and we'll probably do a skill check on them, but let's go ahead and revisit some of this stuff from way back when. Using identities, we're going to evaluate functions or get values, determine or calculate the numerical value of a formula, function, relation, etc. So if I know that the secant of this angle u is -3/2, and I know that the tangent of that very same angle is greater than 0, then I can kind of think about where's this located. Secant is negative, so that means cosine is negative, so that has to be in one of these two quadrants, and tangent is positive, so that means it has to be in quadrant 3. Okay, so I can use those clues. If the secant of u is -3/2, then the cosine of u is -2/3, and that's using a reciprocal identity. Okay, if I want to find the sine, then I'm going to use a Pythagorean identity. And I'll say, since the cosine of theta squared plus the sine of theta squared equals 1, I'm going to substitute the cosine. All right, so that's going to be 4/9, subtract 4/9. Oops. And then I'll just make this 9/9, so that the sine squared theta is going to be equal to 5/9. Then I have to undo a square. So I have that the sine of theta is equal to the square root of 5/3. Okay, and since I know that the sine of theta is the square root of 5/3, then the cosecant of theta is going to be the reciprocal 3 square roots of 5/5. Now, again, we're in quadrant 3 here. So when I take a square root, there's always a plus or minus answer. And in quadrant 3, I'm going to want that to be negative. So the sine, I want it to also be negative. Okay? Then we have tangent. Now tangent is going to be sine over cosine. So we said that the sine was negative square root of 5/3, and the cosine is -2/3. Since they both have a denominator of 3, I can cancel that out, and I'm left with the square root of 5/2. Both were negative, so now it's positive. And then the cotangent, which is the reciprocal, sorry, this was a quotient property. The cotangent is a reciprocal, and so that will be 2 square roots of 5/5. So we found all of them, the cotangent, the tangent, the cosecant, the sine, the cosine, and the secant, all 6 of them. Again, I found all of them by using the identities. Okay. Here's another. So we know that the tangent is 1/3. So I know immediately that the cotangent of x is going to be 3. Tangent, I can use a Pythagorean identity. And I can say, okay, 1 plus tangent squared theta, or x, is equal to secant squared theta. So I have 1 plus 1/3 squared equal to secant squared theta. And so this is 1 plus 1/9. Change the 1 to 9/9. And then I get 10/9 is equal to secant squared theta. So secant is going to be plus or minus the square root of 10/3. Now it tells me that tangent of x is positive. So that's quadrant 1 or 3. And it tells me that the cosine is less than 0, so it's negative. So again, this has to be in quadrant 3. So if it's in quadrant 3, then this secant has to be negative. So we're going to circle the negative. And if the secant's negative, then the cosine is negative also. And so that will be negative 3 squared roots of 10/10. Okay, I can either use the ratio here for my tangent. I can use another Pythagorean identity, which I most likely will use. But I think I'm going to use the cotangent one. So 1 plus cotangent squared theta is equal to cosecant squared theta. So 1 plus 3 squared is equal to cosecant. So that's going to be 1 plus 9, which is 10, equal to cosecant squared theta, square root. And since it's in quadrant 3, we're looking at negative square root of 10 is equal to cosecant theta. So cosecant of theta is going to be a negative square root of 10. Therefore, the sine of theta will be a negative square root of 10/10. So that's 1, 2, 3, 4, 5, 6. All 6. Okay, the other thing is to kind of simplify. We did a little bit of this before also. Anytime you have an expression right here, you want to first say, okay, how can I simplify it? Notice both of these terms has a sine x. So if I factor out a sine of x, that leaves me with cosine squared x minus 1. Now, here's another thing to recall. Actually, we're just factoring, so you can stop right there. There is another way to factor. We can break this down since this is two perfect squares. Cosine of x plus 1, cosine of x minus 1. So I have sine of x times cosine of x plus 1 times cosine of x minus 1. Okay, right here, what do these two terms have in common? A cosecant of x. So if I factor out a cosecant of x, I'm left with cosine squared x minus 1 again. So I have cosecant of x times cosine x minus 1, cosine x plus 1. And these are factored. Okay, so your assignment is out of the textbook, page 354, numbers 7 through 32. There's a little bit of simplifying and factoring, as well as evaluating.